Hey guys, this is my ENME351 final project, which I've chosen to do about blood sensing. So the idea is that when you have like surgeries in the body with catheters or some sort of equipment of a similar shape, a lot of times you only have vision and movement at the very tip, so you can only see what's ahead of you. And the idea behind this project is that if you have to shove the catheter in there or navigate to wherever you're working on, but there's a chance that you're going to cause like damage behind the head of the catheter or the endoscope or whatever. So you can't tell whether you've caused internal bleeding behind the catheter. So my idea is basically just detecting whether there's any sort of bleeding going on. And of course, this would be better. This is more of a proof of concept. Like if you actually put this in the body, you'd want to make it smaller, waterproof, and wireless. But I think this turned out pretty well in terms of sensing whether there's blood being lost. So the way I've set it up is I've got a little pump here that's taking in either water or blood. And then the way I'm sensing whether it's blood or not is using a photoresistor and an LED. The LED is taped up there, so it's kind of only shooting light directly through the piping across to the photoresistor. And so basically, the blood, when the blood goes through the piping, it absorbs the LED. I picked a green LED, like it's a green-blue. So, and that was the color that would be most absorbed by the red food coloring. Don't worry, it's not real blood. And then I have this little cover here that I put on it to prevent like outside light from messing with the photoresistor. And then the pump is controlled via the H-bridge we used in one of our previous labs, lab 8, I believe. And then the sensors, the LED is a digital pin and the photoresistor is an analog pin. But let's turn over to the processing here. And basically what I've got going on here is, right now, obviously we're not looking at the blood, so it's not going to be bleeding, but we have an indicator of whether it's bleeding or not. We're graphing blood loss versus time here, with 10 milliliters being on the Y. And then we have a progress bar towards 100 milliliters that would fill up if we were losing blood. And we're tracking the amount of blood loss, and that's by knowing what the flow rate of the pump is. So if I switch this over to the blood, you'll notice like the red will go through the pump obviously, and then it should change over here once the red gets into the pump. Yeah, so now we're bleeding as marked by the indicator. The total amount of blood loss is increasing. You'll notice the bar is increasing towards 100 milliliters. And you've noticed we've switched to red, and that's increasing over time across our graph, which I've made to like reset once you reach the Y limit of the graph. And so then if we switch it back, we should eventually get back to not bleeding. Okay, so now we're safe. And the quantity of blood has stopped increasing. Same with the blood over time. One other thing, one other thing I did add was like a death screen, basically. Obviously this pump is not pumping a lot, so you're not gonna hit the like 2 liters that you would require to bleed out to die. So I'm just gonna change the death screen to be if blood lost is greater than 1 milliliter, so we'll get a chance to see that. Now we're bleeding again, and let's see what happens when we get to the 1 milliliter that we've defined as death in this case. Yeah, so we got a nice, real encouraging message there. You are dead. Anyways, that's my 351 final project. Thanks for watching.